up this notes and make it available for you, right? So you have this notes to go through as well.
So you'll be doing this over
Yeah.
tomorrow as well, or you're doing something else tomorrow?
What's that, Caleb?
You'll be doing this over tomorrow as well?
No, tomorrow's a different topic. Tomorrow they kind of start over and they're doing they're doing mechanics.
Okay.
Okay, right.
Well, I watch on the board because this one is the kind of advanced class.
No,
Do a little more.
Simple. Watch it and see. Yes, last week you were just in the wrong class, remember?
Oh yeah.
All right.
Yeah.
Right. So here we have a wave, right? You're seeing that? So we'll be continuing on the amplitude, next head period and frequency. Okay. Huh? Let's go it over again, right? So if you look here, we have a wave. This wave has 3 cycles, right? How do we identify a cycle? Right? If you look here, a cycle in this case starts at 0 displacement, goes up to the amplitude, then comes back down to 0, back to negative amplitude, back to 0. That's one entire cycle, right? So it starts here, goes up, come back here, goes up, come back down here. That's one cycle. The time for one of those cycles is what we call the period. Everybody have that definition? Period is time for one cycle. Nice. So what you're seeing in front of you there, how many cycles? How many cycles in front of you there? 3 cycles, okay? Right, I want to focus on something that we need to be able to draw. Look at this wave here. Just trying to blow up one cycle, right? But from here to here is one cycle, right? How much is this here? Half a cycle, nice. How much is underneath here? Our next half, right? Okay, good. So if I draw from here to here, how much is that? Quarter cycle. Okay, so we need to look, we need to know to identify those two, a half and a quarter cycle. Everybody okay with that? Nice. So we know what is period, but what does frequency represents? Right? Frequency represents you have it there. Frequency represents the number of cycles in 1 second. Right? So make a note of that. Frequency. That's the number of cycles in 1 second. So in our example, watch it good there. In our example, how many cycles did you have in 1 second? 3 cycles. That's okay? So your frequency is 3 SI units is hertz. Okay? Had that already? Well, you have that already? Pete, why like Pete, you want to come in front here? I find you distracted there. Okay, so make a note of that, please. Frequency, number of cycles in 1 second, right? Number of cycles in 1 second, SI unit, hertz, HZ. Okay, that's the SI unit, HZ. Right, I have a little question as well. How do we know how do we work out the period? What's your idea? Period is, what does period represent again? Time for 1 cycle. Okay, time for 1 cycle period. So I need to figure out how to get period. How are you doing that? Good job, Katrina. 1 over the frequency. So if you look here, the frequency is 3. Right? So we can do a little bit of maths. 3 cycles in 1 second. So therefore, 1 cycle, you divide everything by 3. 1 cycle will be 1 divided by 3. Right? So 1 cycle takes 1 over 3 seconds. So therefore, period is always going to be 1 on frequency. Right? Make a note of that in case I didn't give it to you. Period is equal to 1 on frequency. Period is 1 on frequency. Make sure you remember the SI units as well, right? Period is capital T, yeah. Right, for those who are not paying attention, period is capital T and frequency is permanent, right? Nice, quick reminder, what does MS mean again? Huh? In terms of time. Sorry? Milliseconds, right? So that'll be by 10 to the minus 3 seconds, right? Don't forget that when you see it, right? That's not meter second. Okay, time can be meter second, right? Okay, good. So there's a quick little intro there into that. Next quantity is what we call wavelength. Wavelength represents the distance between, so write this down. Distance between two successive crests, troughs, or points in fields. Distance between two successive crests, troughs, or points in fields. Come on, Tony, ready? Ready? Finish your note. Finish your note, please. Tell right then. All right. Distance between two successive crests, troughs, or points in fields. Right. Anybody knows our next definition for wavelength? Definition for wavelength. There's one more definition. Anybody knows it? Yeah, we'll just see it now. Yeah. Length of a wave. Right? So the length of one cycle. So make a note of that. Wavelength is the length of one cycle. Length of one cycle. Quick question. How many cycles we have there? So how many wavelengths we have there? 3. That's okay? Right. I would like to know, so think about it. I'm going to ask a few questions. You're okay with that? We have 3 waves? Yeah? 3 wavelengths? Yeah? Right. I have a little question, right? How much of a wavelength is this? I start in here and I finish in here. Take your time, huh? How much of a wavelength? 1 whole wavelength, right? That's 1 whole cycle. Easy, right? How much is this? Half a wave. Very good. Half a wave. How much is this? Quarter of a wave. Okay? That's 1/4 of a wave. Nice. How much is this? Message online. What you all think? So after I went through all that, that's what I'm going to say. Quarter.
So you want to know the distance?
Yeah, I want to know how much of a wave is that? What wavelength? Half, a whole, a 3/4, 5?
It's a whole cycle and a quarter.
Okay, that's not what you see. Who say 1? 1? Who say 1 and a? I'm gonna get the correct answer. 1 1/4. 1 1/4. No 1 1/4.
I say 1 1/4.
All right. All right. So what is here? 1 1/2. No, the answer is 1. Just put your 1. Right, so watch this here. How we know that? Because the definition of a wavelength is what? Crest to crest. Or you can do it like this. Here to here is 1/4. Here will be a half, 3/4. A whole.
All right. Yeah. It's a one. It's one.
That's okay?
Yeah.
All right, nice. Let's do one more. How long is that? Take your time, message your answers. Children, once in the class, you want to answer. I just want to go outside. I'll take some. Then in physics in school? Think about it. How much is that? What? All right, so what we need here to see is how much is this? So from here to here to here is a whole, right? And here to here we are a half. Okay, so the answer is 1.5, right? Nice job. So we know about that. We know about wavelength. Oh, what's the SI unit? Meters, right? The SI unit for wavelength is meters. So we did amplitude, frequency, period, wavelength. Just now we'll do phase, right? One more thing we have to do is speed of a wave. All right. So how do we find speed of a wave? How do you find speed again? Speed is what? Let's use V, right? So V is speed. So next subheading, speed of a wave. I'll explain phase just now. Next subheading, speed of a wave. And see if we can remember from primary school how to find speed. Speed is distance over time. Right? Over time, Sebastian. So here's the problem, all you. You need to find a way to create a formula for speed of a wave. I know some of you all did it already and you know the formula. But we need to find a way to create a formula for speed of a wave. All right? Let me just pick on some of Malachi. What period again? Jacob, what's wavelength again? Or what's the last definition I give you? Length of a wave. So I have a little question, right? And I want you to help me fix this formula for me. We know the distance, we know the length of a wave, and we know time for one wave. I have a quick question, and we can help me come up with a formula. I want you if you could use this and come up with a formula. Speed of a wave. Wavelength over. All right, then I'm write it down. I want to simplify it a little bit further. Well, again, sorry. Again, some good things. So write down what I have there and see if you can figure out a formula for speed of a wave. Oh yeah, try that come up. So substitute what these things are and where it comes with a little formula. What do you come up with? No, symbol. Not the SI unit, symbol. Right, sorry, in case I didn't give you the symbol for wavelength. It's lambda, right? Back to front page, lambda, lamina. Lamina. Finish? What you all got? All right, so let's see. Here's what I was hoping that you had, right? We know that the length of one cycle is wavelength, right? And we know time for one cycle is period. That's okay? Wavelength and period. But and we also know that frequency is 1 over period. Yeah. Or period is equal, if I rearrange that formula, period is 1 on frequency. Correct? So here we could do. We could say that since period is equal to 1 on frequency, then speed is equal to lambda divided by period, which is 1 on frequency. Do your little maths, and you'll get lambda multiplied by f over 1 f lambda. So the formula I want you to come up with is B is equal to f lambda, or B is equal to lambda and T. Anyone could work. Okay, that's the way you find speed of a wave. All of my markers are dead. Dead. You gotta finish up class earlier. I don't want markers. Huh? If this marker don't work here, you gotta finish up class. I'd love it.
Sir. Finally got
Sir.
So don't forget to add many group, please. You forget to add many group.
Yeah, was that killer belly here? Yeah.
Don't forget to add many group, please.
Okay, yeah. Yeah, killer.
Yeah.
I keep forgetting.
And yeah, I need the notes and stuff.
All right, no problem. Ah, D/M, yeah. Right, anybody writing on the board? Anybody writing on the iPad on the screen there? No? Oh, yeah, writing? We're missing. Oh, wait, hold on. Sometimes. All right, so let's go to the board. Hello, seen somewhere else, huh? I was wondering now myself. All right. So let's go to the board. And from the board, we want to gather a few things about the wave, right? We want to gather a few things about the wave. Right? We would like to gather amplitude from the wave, wavelength from everything that we just did. We want to gather all those things from the wave. Right? So let's do my favor. Do my favor, draw this wave. And let's see if we could get amplitude, period, frequency, speed, wavelength. Let's see if we can get those four things. If you can't, don't worry, I'll show you. Right, but you should be able to get these two things from it. From that, we need to see how to get amplitude, period, frequency, speed, and everything on the wave that you need. There's only one thing that we have to work out, right? Maria, you okay there? Can't come in already? Okay, that's how you next step. All right, let's see what you got now. So what does amplitude represent? Amplitude represents the maximum displacement. That's okay? So the maximum displacement from where you start is 2 meters. That's okay? You're seeing that? So the first part is the, yeah? Why all those blank? So tell me out here then. Period. Period is what? Time for what? Check back and see. Is there any phone of that? Is there any phone of that? Tell me. What does period represent? Time for what? No. What it represents? We do have frequency. Period is what? Check the definition out. Period is time for what? You right, you know? That's some last day. Period is what it's time for? One cycle. So one cycle takes how long? 10 seconds, right? But sorry, 10 what? Right, 10 milliseconds. So that is 10 by 10 to the minus 3 seconds. That's okay? So one period takes 10 by 10 to the minus 3 seconds, or you can write it like this. 1, 2, 3, right? So that's 0.01 seconds. Okay, better to work at it like this here. Are you okay with that? So it's not 10 seconds, it's 10 milliseconds, right? How do we find frequency now? Jacob, frequency is what? 1 over t. T is not 10. So that's 1 over 0.01, which is 100. How much earlier? 100, right? 100 hertz. Look at the graph. What do you think is the speed, Aiden? Aiden, what do you think is the speed of the wave there? Aiden, you there? Aiden said 4. Very good. If you look here, you see the speed of the wave. You recognize that? See that here? So I told you that the speed of the wave is 4 meters per second. So we simply write 4 meters per second. Right? I need some help. When pick on Malini, I pick on yours here. Yeah? When? Today? Yes. Malini, I need some help with Malini. How do I find wavelength? I have amplitude, period, frequency, and speed. How do I find wavelength? Yeah, Malini, how are we doing that? Right here, Kelly, any idea? How we getting wavelength from what we have here? Huh? F by B, you sure? So we'll be using B is equal to F lambda, right? So when you make lambda the subject, what would it be? V over F. Right. So lambda is equal to V over F. V is equal to 4, F is equal to 100. So see that? So the answer is 0.04. Okay, that's the way you find speed of a wave. Sorry, wavelength. Where you get lost? And where you get lost? Because I'm bringing forward to the next one. And where you get lost? After F. How I get F? So I use the formula for F. F is 1 in period. And I found the period here. I found the period here. So I put 1 over that and I got 100. Right? And once I figured out frequency and I know speed, I can work out wavelength. All right. Copy down. Let's try one more like that, and then I'm going to give you the reverse. Copy down. Copy it in there, right? Try this here. I gave you a hint. Watch. Excuse me. I gave you a small hint, right? Right? If you look here, the hint really is this. Watch. I've told you the order to go in. This is a different graph. This is a displacement versus displacement graph. So you cannot read off time. So think about it. You cannot read off time from this graph. Okay? You can only read off a distance from this graph. Right? And I gave you a little hint here of how the order to work in. I'm gonna see what you do. Take your time, huh? Don't go in the same order. Do that, please. Let's see what you got. Take it out and see. What we got? All right, so we should be able to read off amplitude. Amplitude is the maximum displacement, so that's 4 SI unit meters. Right, you will notice every time I take a value, I come in here to make sure I have the right SI unit. Okay. Velocity right here, that's 10. I'm not just writing 10, I'm writing 10 meters per second. Okay, wavelength. This tells me that when I read this value of the length of a cycle, again, the wavelength, because this is not time. So when I read off how long it takes for one cycle, that's a wavelength. Okay. If this were time in seconds, then this would have been period. Then this would have been period. Okay. So if this was time, I'll get period. If this was distance, then I'll get wavelength. How do I get frequency now? Any ideas? Attilia, how do I get frequency? Anybody can help her? She's not too sure. Right. Very good. So you got speed what? Speed over lambda. All the people who bad at making the subject and the formula, they can do this, right? Speed is equal to F multiplied by lambda. So if you want to make speed the formula subject, F by lambda. If you want to make frequent lambda the subject, V over F. If you want to make F the subject, V over lambda. Okay? So if you know you're bad at making the subject and the formula, learn to make it subject and the formula. All right? Oh yeah, finish up those two things tomorrow we're done. With that topic. Let me go down to NT. Right, so let's check out right, so F is equal to V on lambda. V was 10 over 10, so that's 1 second. Correct? Yeah? What do wrong? Wrong SI unit. Oh yeah, 1 divided minus 1. 1 hertz. Okay? Frequency is in hertz. Right? And I'll pick somebody online. Samir. Samir, there? Right, Samir. How are we going to find period now? How are we going to get period there, Samir? Wait, do you have one there? Oh, I know that. Yes, Samir. So I have frequency. Yes. You sure? Check with the phone if it's period. What is period earlier? Period is what? We don't know, we just do it. It's still on the board. Well, one version of it. Kilon, period is what? Highest time period.
So half of it, so it could be like 10, so it'll be 10.
Whatever period is
it-
1 on F. 1 on F, so that's 1 on 1, so that's 1 second. That's okay?
Yeah, it took
Caleb,
it one.
you okay with that?
Yeah, yeah.
All right. Okay. All right. So that gives us a little idea. Normally we'll go in reverse, but we'll stop on that. Head up outer page. I want to make sure you have all the characteristics. Before I forget, I'm going to read up on all the wave phenomena, things that we want to do. All right. Right. On. Let's now head up to all the page. Right. Head up. Please. Head in this page. Head up page.
So what we heading up?
Where? All right. Caleb.
Excuse what
What's
we
that
heading
there?
up? What we heading up?
Oh, we're looking at phase difference.
Okay.
Phase difference. That's the last characteristic that we need to know, right? So we need to understand two concepts. When they say waves are in phase and when they say waves are outer phase. Anybody who did it already knows? Anybody? Can remember? Okay. So when they're in phase, it means that the waves should perfectly align. When they're outer phase, it means that the waves are totally the opposite. Okay? So we need to draw that, right? Ricardo, take off your headphones so not please. Okay. So as I said, we want to know two different things, right? What do you mean by in phase and outer phase? So let's say I gave you two waves, right? Normally I'll show you a simulation, but you know how long that takes to step up, right? Let's say I gave you a wave like this, and we overlap this wave with a wave looking identical to it. Right? So these two waves here, the crest meets up with this crest, and the trough meets up with this trough. So crest and crest lining up, trough and trough lining up. Okay? And this is crest and crest, trough and trough. They both lining up. And in this example here, notice that the crest lining up with a trough. So the crest lining up with a trough and a trough lining up with a crest. Right? If you had to make a wild guess, which one you would say in phase? First one, right? These two waves are perfectly in phase. Right? Crest and crest lining up, trough and trough lining up. Okay? These two on the other hand are what? Outer phase, right? These waves here start to be out of phase. So the two main types of phase difference, and there are a lot more, right? There are a lot more. Imagine this shift by quarter wave. That has different type of phase difference. Okay? So if you look here, this is in phase and this is outer phase. So when the crest lines up with the trough, that's outer phase. Okay? I have a little question. Right? I have a little question. How do I turn in phase to outer phase? Huh? Somebody saying something. Make up? Right, but by how much? How do I turn a crescent? Sorry, how do I turn in phase into outer phase? But I almost tell you the answer there. Turn the How are you doing that? Right, Faith said to turn the crescent into a trough. What else you can do? How do I turn this into being outer fields? Right, Faith said to turn the crescent into a trough. That's half the answer. And the half is the hint. Huh? Turn it. But by how much? By how much? Push it up. Half a wave. Right? So you can look here. If I were to move this wave half a wave, what happened? Trough will line up in with the crest. If I were to move this half a wave, or move it back this way. Now, here to here is how much of a wave? Half a wave, right? Here to here is a quarter, here to here is a half. But remember that? So if I move this half a wave, this will line up with this. If I move this half a wave, this will line up with this. You're seeing that? Are you sure? Everybody seeing that? So in words, out of phase is really a phase difference of how much? Very good. Right? That's a key thing that you all just learn there. You'll do that in unit 1. Right? This is a phase difference. This is the phase difference of half a wave. Very good order. Very part difference, but right, but for now you all should catch up. Are you clear that? Yeah. Friday, you know what? You know what? I thought this month Friday, right? All right, so it's important that we understand in phase and outer phase. Any questions online? Online
No,
questions?
I good.
Right, I just have one more little challenge for you. Oh, we have some time. Right. So you have in phase and outer phase, right? All I really want here, I would like you to draw 2 waves. 2 waves on the same, but let me draw the phase first one. I want you to draw a next wave, a dotted wave, that outer phase, right? Or has a phase difference of 1/4 wavelength. So I want you to draw something with a phase difference of 1/4 wavelength. Think about it. That's it. Where are you going? Right, so I want you to try something there. Draw 2 waves around. And the second wave has to be a phase difference of a quarter. And as Sherelle said, a quarter. No, I think I have part of it here. I think I have some idea. Let's try and remember which one is ours. The one with V on it, that would be parts kilowatt. The one with V, it should be max. This is max form 4. Add max form 4. So I didn't do this last week earlier. No, no, this last. Oh crap. All right, before we go, let's put a name on this. Name contact number. Right, so put your name. Yeah, name, number, parent. Right, and if you want to, if you want to move this, just like that, you have to move this up a little. Normally I'll show you the simulation, but I don't want to waste time behind that. Right, so I want to see a draw wave, a quarter of a wave. Right, was that there, Sebastian? Yeah, all you have to learn is outer phase and in phase, Sebastian. Right? That's all you have to learn. For CSEC, outer phase, in phase. I just kind of want to just show you something there. Let me see the quarter. Who have it? So it had to be quarter of a wavelength. Right? Yeah. Where's quarter? Underneath at that time. So what's it there? It was a tricky question. I wanted to see if you would have gotten it. So if I said half, and you would have started the wave a half wave here, and then you would have drawn back that part there. If I said a half, if I said a quarter, all right? All you have to do is this. A quarter is right here, correct? And that's a quarter. So if you start a wave a quarter later, this will happen. Right? It's not showing up to be a schedule program with that blue, right? And then it just start the wave like that. Right? That's a quarter of a wave later. Everybody okay with that? See that? I'm just going to show you one more time. Right. So as I said, here's a half a wave later, here's a quarter of a wave later. So if I say a phase difference of a quarter, just start the wave a quarter later. Okay with that? Just draw the little piece that missing here. That's it. Right, and just continue it out. Everybody okay with that? Okay, so now we learned all the characteristics of waves. Our next step is to go into the wave phenomena. Right, wave phenomena is reflection and refraction. Homework, I just going to go through those to